So now, to introduce the next two awards, I would like to welcome Dr. Mike Salter to the stage. Mike is the Chief of Research at the Hospital for Sick Children, a senior scientist in the program in neuroscience and mental health, and professor of physiology at the University of Toronto. Former colleague of mine, I guess still a colleague of mine at SickKids, a longtime friend of the Gairdner Foundation, and a member of our medical review panel, the Canadian Adjudication Committee, responsible for the first tier of our nomination reviews. So Mike, please join me on the stage.
You know, technically I'm your boss now, which is impossible, I know. So it's a great pleasure for me to introduce the second of our 2017 Canada Gairdner International laureates, which is Dr. David Julius. Some of you will know that Dr. Julius is chair of the Department of Physiology and the Morris Hertzstein Chair in Molecular Biology and Medicine at the University of San Francisco, at University of California, San Francisco. So I've followed David's work for many years. I'm a pain neurobiologist myself, and David is an exceptional person. He has used an array of exotic molecules that come from the natural world, toxins from tarantulas and coral snakes, wasabi and capsaicin, the hot pungent ingredient in chili pepper, to really round out the entirety of molecules that are involved in what we call somatosensation, the ability of the skin, muscles, joints to detect sensory stimuli. David truly established a field on his own when he first cloned the receptor for capsaicin, a molecule we now call TRPV1 or TRPV1. At the time we called it VR1. This discovery by David instantaneously transformed the field of somatosensation and really created this own field on the molecular basis of sensation. This was important not only because this molecule TRPV1 was a receptor for capsaicin, but is also one of the main pain detectors in the body, responding to noxious heating and also to a whole variety of different stimuli. Not done there, David used his array of exotic molecules to clone an entire family of TRP channels that respond to many environmental irritants. And one that you might be particularly interested in is the receptor for menthol, this cooling compound that you feel cold. David cloned the receptor for that as well, and that turned out to actually be a real cold detector. So David truly has had a remarkable impact. His research is not only fascinating, but it has practical implications. Virtually every pharmaceutical company in the world now is searching for TRPV1 antagonists as potential painkillers. And the medical implications of this are that pain, chronic pain that's untreated, is one of the largest health problems globally. And the disability from chronic pain is bigger than cancer and heart disease combined. So let's say congratulations to Dr. Julius. And now we'll have a video about Dr. Julius describing his research.
So the challenge that we set out to solve was to understand really what we colloquially refer to as our sense of touch, or somatosensation. So that includes things like your ability to sense changes in temperature, hot or cold, pressure, and all manner of things that cause pain, which can be both physical and chemical in nature. I think the impact of our work on the scientific community has been different in different levels. I think, first of all, the sense of pain and somatosensation, among our senses was one that was least understood. And I think our studies really sort of helped to bring a molecular framework to that. Well, I think hopefully one of the big impacts of our work will be to identify new strategies for treating chronic or persistent pain syndromes. We all know that there's a real lack of drugs and approaches to treat chronic pain. That's in part and parcel why we have this opioid epidemic that surrounds us. I think we need some new insights and new ideas for treating pain pharmacologically and other ways, and I think our work will contribute to that. This is a big award, I think, in the pantheon of scientific awards in biomedical research. This is one that we all know about. It's you know, it's exciting and humbling at the same time.